Okay, in this video we talk about the UV analysis of biopolymer, meaning how one can understand or inspect the presence of biopolymer in an UV spectrum. Okay, now the biopolymer example protein usually when kept in an UV spectrophotometer it will absorb light at some particular wavelength. The region where it shows the larger absorption is called a chromophore, meaning chromophore would be a part of the protein that absorb in a larger scale, meaning it may dominate the spectrum. That is called a chromophore. Therefore, while you examining the UV spectrum of a biopolymer, usually the chromophore will absorb light lesser than 300 nanometer. That's the first information one should derive. But but the point is, solvent also plays a very crucial role in determining the UV absorption. And therefore, what solvent to be taken to study the polymer in an UV spectrum photometer? The solvent usually preferred is water. Why is it so? Because of having greater solubility and the pH is around 7. These two factors make the water as a dominant solvent to study the protein for a UV spectrum. But the same water also comes with some limitations, meaning it lay restriction in absorption. It hold the free absorption of the protein. Why it arrest some absorption or alter the absorption pattern? It is because due to the solvent-solvent interaction or maybe solute-solvent interactions, or it is being a polar solvent, it may contribute for the dipole effects. Because of these things, sometimes the real structures of the protein may to some extent hampered or affected by the solvent, exclusively water. Having given that idea, we can now inspect the protein in an UV spectrum. In an UV spectrum, the UV region itself can be classified into two. One is far UV region, which spans between around 190 nanometer to 230 or 240 nanometer. The other region would be near UV region, which is around 230 to 240 to 300 300 or 340 nanometer. So I repeat, far UV region spans between 190 to 230, and near UV regions comes after it, that is at 240 to 340 region. So these are the two important regions present in the UV. I mean, now how to go further? We can now understand the chromophore by three ways. Assuming the chromophore as a peptide bond itself, or considering the amino acid side chain residue, or the prosthetic group. These are the three important groups which are attributed for a chromophore, which show a significant absorption in the UV spectrum. Let's focus our attention towards a peptide bond. In peptide bond, so what is a peptide? A peptide is this. Okay, this is the peptide. That is the carboxylic group OH and the amine group of another protein fuses or condenses such that water is eliminated, and there which there is a bond, new bond formation. This bond is called peptide bond. So this is why the peptide bond. In the peptide bond, the chromophore or otherwise the absorption mainly takes place between the electrons resides on the oxygen. Okay, if it is a formaldehyde, we can clearly tell that the electron, the lone pair of electrons always associate with oxygen, which shows a strong pi to pi star pi to pi star absorption. But as far as amide is concerned, there is a possibility of the delocalization of electron. Because of this delocalization of electrons, the electron may not picture or may not present exclusively on the oxygen, but it will be spread all over the ring, meaning it spreads across carbon, nitrogen, oxygen. Which carbon? This carbon. See, oxygen, carbon, and nitrogen. In the three atoms, this electron will spread. When it spread, and that leads to a weak interaction with and that is attributed for n to pi star transitions, and it shows very weak intensity, probably epsilon max, that is intensity would be around only 100. Okay, so it undergoes a weak transition. That's why usually at the region between 190 to 230 we can expect for a band. If at all, if there is any band, that band should be caused by the peptide group. That's the idea that one can derive just by inspecting the UV spectrum. Okay, we have an example. This is a UV spectrum of poly L lysine. This is dissolved in water, so we are taking aqueous solutions. It is having various structural features. Probably in one end it acts as a coil, in the other end it acts as a beta sheets. So it is existing two structural features depending on the pH and as well as the temperature change. No matter whichever the structure it stays, it shows the absorption at this range, right? So this is attributed for the N to pi star transition, and that clearly assigned for the presence of peptide-peptide bond. That's what justifies. A peptide group usually dominate at the far UV region, and that has been proved over here. So while you inspecting a protein in an UV spectra, if you find any absorption near at 190, for sure we can confirm the presence of peptide group, that too in the far UV region. Okay, going for another typical example, mystery amide. This is the mystery amide. In the mystery amide, usually the pi electron should be present on the oxygen, as well as there must be a lone pair electron to be present in the nitrogen. But realistically it is not happening. What really happens is this lone pair electron circulates on these three ends. Okay, so this electronic transitions can be movement of this electrons can be noted by the transition dipole, and this transition dipole occurs to the plane bisecting or near to this group, and that is why rather than the expected pi to pi star transition, okay, the expected is pi to pi star transition because the electron has to be on nitrogen as well as on the oxygen. If they stays in the oxygen and nitrogen alone, you will be expecting a pi to pi star transition. But unfortunately, the electron delocalizes. Because the electron delocalizes, pi to pi star transition did not happen. It is forbidden. What really happened is n to pi star is happened. Maybe at higher concentration or at higher energy, this even changes from n to sigma star. Okay, so this is what really happened. So this clearly tells that at far UV region, the peptide dominates the spectrum. Thank you very much.